All right, this is 10 minutes with ClojureScript, give or take. My name is Jonathan Boston. Everybody calls me Boston by my last name. I got my degree in computer science from OU back in 2005. Lived in Nashville for a while, and family and I just moved back to Norman about a year ago. And since I graduated, I've been writing JavaScript, PHP, and Rails, and then I'm doing full-time Clojure and ClojureScript since about 2012. So I want to show a little demo. Whenever I do talks, I try to give something useful. ClojureScript is awesome, but a lot of people can't just go and use it. So it's kind of a challenge to do 10 minutes of something that most people don't know a lot about and make it useful, but I'll try. So here we have an example of, these are two cells, it's just a table, and I want to set up the idea of having separate threads, right? So we're going to have 3 threads. One thread is going to, one thread for each cell, right? And then one thread for rendering. So each cell is going to basically generate some data, which is just going to be a number, and then pass that to the thread for rendering. And then the rendering will process that thread and update each cell. All right, so if you see that, each one of these is effectively running a separate thread and then passing it to the render queue, and the render queue is just processing, waiting for each, processing the queue every 16 milliseconds, and if there's data there, then it updates. All right, and so the idea is, how do you get threads in a single-threaded environment, right? And what does this actually look like? So here's another example. Same exact code, except instead of 2, we have 10,000. Right, and so each cell is running its own independent thread and pushing this data to a queue, and then there's one queue that's just processing each one of those. All right, and we have a text field to show no jank. Right, we can still interact while it's working. All right, so again, just an example that I think is cool about showing threads, and kind of a good example of some of the cool things about ClojureScript. So I'll take a few minutes to walk through some of the code. Has anybody ever actually even seen any ClojureScript? Familiar with it at all? Okay. ClojureScript is a Lisp. It's a Lisp that runs, compiles to JavaScript. And it also compiles to Clojure, or to Java. So you write it in Clojure/ClojureScript, and you can compile to either Java or ClojureScript with specific details depending on which runtime you are targeting, and food's here. So here's effectively the thread for processing. So you're going to start with what's called a go loop. And this, a good way to think about it is it's just going to spawn a thread. Right? And then for our processing, we're just going to set up an infinite loop that says, hey, just keep going, do something, and then just start over. All right. So what we have here is, this is built on channels. If you see on the bottom, it's communicating sequential processes called CSPs from a guy named Tony Hoare. So if you're familiar with the language Go, Go has channels built in. And so Clojure basically took that idea from Tony Hoare and from Go and added it. So what you have is a timeout that takes 1,000 milliseconds plus some random number between 1 and 10,000 and uses that for a timeout. So effectively this code says, hey, I want you to block for somewhere between 1 and 11 seconds. And then take whatever the index of the cell is and some random number and push that to this other thread's queue, and then just go back and wait. All right, and so again, this is the infinite loop that's running in JavaScript and doesn't block everything else, which is pretty cool. Right, so then you have the render queue, right? So you have effectively 10,000 of these Go blocks running in the example I showed. So now you have your render queue. So first you start with a channel, and a channel is effectively a queue with synchronization. So if you think of a queue with one person placing on the queue and another person taking, you can synchronize based off of that. So the person putting on says, I put this on, and the other person waits. And as soon as something comes, that's a signal, okay, I'm ready to work. And so you can say, okay, I want a buffer of only one. So whenever someone comes to put something there, if something's on that queue, they know to wait, right? So you can synchronize the work based off of that. And so we set up a channel with a buffer of 1,000. So that means it will accept up to 1,000 events, and past that, whenever you try to put something on, you have to wait. So then you're going to set up another infinite loop, which basically just has a timeout, which is the rate of 16 milliseconds. So it says every time, wait 16 milliseconds, and then send a signal that it's ready to go. So this is how alts is you take two channels, and you basically just wait and say, what's the first channel that gives me a result? So you're waiting on two queues, and the first queue that actually has data on it, take from that one. Right, so we have our refresh rate that says, hey, we're ready to render everything, or you have the render queue, which the other threads have put stuff on. Right, so either one of those is going to get a value first. So if it's time for us to refresh, then we go ahead and render everything that's in the queue, and then we do a timeout of 0 seconds. This is basically a yield, right? We do a render and then yield and say, hey, someone else can do whatever they need to do, and if not, we're ready to go. And then start over, just go back to the top of the loop, which is what recur does in Clojure. Otherwise, we've gotten data from our render queue, from another render thread, and it says, okay, grab that value v, put it on the queue, and then go back to the top and wait again. All right, so this is the thread that's running that's handling all of the rendering. All right, and so anytime somebody talks about their new technology, we all know, right, to ask about trade-offs, right, because nothing's free. We like to talk about how great everything is, but we also need to talk about what we're giving up. In ClojureScript, they're not real threads, right? JavaScript is still single-threaded, and so ClojureScript cannot magically change that. In Clojure, you have both real threads and then simulated threads, like we use in ClojureScript. You have to be aware that you don't have real threads. So if you do tons of processing in a Go block, that's going to block until that processing is done. And the Go blocks are cheap. Like we just created 10,000, and it just wasn't a big deal. But you do have more overhead than using something like native promises. And so if you're looking for extreme performance, then you would either need to rewrite it or choose something else. But one of the things I love about ClojureScript, like I said, I've been writing this since 2012. I don't really know JavaScript anymore because I haven't written JavaScript for years. But I think ClojureScript really gets at what we talk a lot about, JavaScript fatigue, and it pushes back on that and instead chooses a stable API. And this, I think, is maybe the biggest selling point of ClojureScript. The demo I showed you was written in 2013, and it looks exactly like code that we write today. It ran with 0 changes, and it's about 62 lines of code, right? So when you have, the new, ECMAScript or, whatever it's called, again, I don't really write JavaScript, so I don't know, but when these things come out, you get new things like the fat arrow functions, right? And you have, you had var, and now you have let, right? And you have all these things, right? So if I look at JavaScript today, I almost don't even know what a lot of these, keywords mean, right? Versus in ClojureScript, when we added the Go blocks, that's just a library. So if you have a language like Go, and JavaScript says, oh, we really like channels, well, how do you do that? Most of the time, you're going to have to wait for someone to put a proposal together and add this to JavaScript, and now it's a keyword, and now it's built into the language. Well, since ClojureScript is a Lisp, you can do lots of really cool things, and core async, everything I've showed you is just a library, right? So it's added, and then it works, and as soon as someone's like, oh, I want better performance, you can go to the library, rewrite the internals to use something like promises, and then everyone gets a benefit, same stable API that we've had for the past 5 or 6 years. And so that is one of the biggest things I like about ClojureScript is I learn principles, I learn the API, and then I just get to write code, and I get over learning new things every day that are just really rehashes of things I was learning yesterday. So that's it. I'm Boston OU on Twitter and GitHub, all those places. And I write about ClojureScript, ClojureScript Made Easy. I say I write, I need to write more, but you know how that goes. So that's it. If anyone has questions or thoughts or anything, I'm happy to take them.
Do you use ClojureScript for your job?
Yeah. So I started it. I worked at Vanderbilt in genetics research, and so we did Rails for a lot of the collaboration between scientists, and we got into a cycle where funding would run out, and then you'd have big security issues, and it didn't fit because things changed so quickly. So that's when Clojure is built on Java, which is very stable. So we were able to start building with Clojure and not have all the churn that went on for years, right? So we can build something in Java and Clojure in 2012 and just feel confident that it was going to run without having to figure out how to get people to do tons of maintenance on it. And then I did software for legal services, and we built a big system to basically do e-discovery, and now I do just contract work. So yeah, Clojure and ClojureScript full-time, and I love it. So.
What's the story look like as far as you showed the demo in the browser there? Is there a template that sits above, or what's the bindings look like between the stuff that you're compiling into JavaScript?
Yeah, sorry. So the first question was whether or not I write ClojureScript for a living, and I do. And then this question was, I didn't understand it exactly. So what are the bindings?
Well, so you talked about the render functionality, and the demo up here is in the web browser. So how does it actually bind to the DOM?
Okay, so this code is mostly about the threads and not about the rendering, right? And so again, this was written in 2013 before React had really taken off, right? So we have like 10 lines of code here, which basically just goes and mutates the DOM to create a table with specific classes, right? And so that's not really the focus of this, but ClojureScript uses React, is most of the libraries. And you get things like React, when they talk about advanced performance, they say use immutable data structures, right? Because you have equality, you can do shallow equality is very cheap to do versus deep equality. ClojureScript, everything's immutable. So ClojureScript out of the box is actually faster than just basic React. So again, a lot of the things that in JavaScript, like, oh, we need to do this thing, it's like, well, ClojureScript's been doing this for years. And like, it's just not a thing that we even think about anymore. So like I said, ClojureScript's not perfect. And my goal is not to say JavaScript is terrible or anything like that. I just love ClojureScript, and it really fits for people who want to get stuff done and want to use the best tools, but also recognize that we're professionals and we get paid to actually to solve problems, and we don't get paid to play with toys. That's kind of how I personally look at things. So yeah, good question, but this is more about the rendering code, and this is just manually manipulating the DOM.
I didn't hear you said this, so sorry. Is there a way to pass data between threads?
Yes. So you have what are called channels. Thank you. How do you pass data between channels, or can you, between the threads? And you do, and so you have channels are effectively queues, right? And so if you think about a queue as basically a window between two rooms, right? The only thing you do is you can pass something to the other room, and you don't know what happens to it. And you don't even know if anyone's over there. You just stick it there, right? And so that's what you have, right? When we create this chan right here, that's a channel, which is what we pass this cell index and the random integer. So channels are queues with synchronization is effectively the way to think of it. So this is a lot to just dump on you. So really, I was just kind of trying to show off something cool. But if you want to read more about it, it's communicating sequential processes, CSPs, and again, Go is a language that a lot of people are familiar with that implements it. Yeah.
Just have a question in terms of syntax.
Okay, so the question was about the syntax of Clojure. And Clojure is a Lisp. Some people say Lisp stands for lots of idiotic, stupid parentheses. And what's funny is it's really not any more parentheses than any other language, than something like JavaScript. It's just you start with parentheses. And it simplifies things a lot, actually. Right, so that's how you would write plus in Clojure, right? So the first argument is a function, and then everything after that is an argument, right? Versus if you wrote this in JavaScript, right, that's what you do. And so you get simplifications because I ask you, all right, the third character in that function, is it a number or a operator? Well, the first line is just a number, you just know. If it's not the first one, it's an argument. Versus the second one in JavaScript, you actually have to parse that out and figure out which is which, right? And so ClojureScript, Lisp in general, you can write macros, which is what QuerySync does, is how do you write a while loop, an infinite loop that doesn't block in JavaScript, right? You actually can't. So what Clojure does is before it actually sends it to the browser, it rewrites that code. So when you actually look at the code, you really don't have a while loop. And you can only do that if you have Lisp, which is an important part of the parentheses, which probably have to get into in a different time, but it's Lisp is really the answer to that. Questions? All right, well, thank you. I appreciate it.